Chemistry. Okay. Hello, we're going to talk about heat and stuff. So, the equations that you have been working with on your homework are as follows. We have this one, mc delta t, or if you want to think about it the other way, c is something, q over m delta t. So really they're the same equation, just rearranged a slight little bit. So, these are the two. These are part of entropy. And we're going to get to entropy in the second video. So for now, just know that this is part of entropy. So what you need to know about these things, Q is the heat, which really you can think about as energy. They're the same, it's a general sense. Heat is the amount of energy in a thing. M is the mass. C is the heat capacity. And, of course, delta T is delta temp. What's the change in temperature? A couple of things to note. This, the heat, or the amount of energy in a system, is what this is representing. The heat capacity is the amount of heat that an object can take. So, for example, we could say that this has, let's make up a number, 3 for a heat energy, which means that this has 3 unit of energy in it. Whereas the heat capacity could be something like 5, so that means you could add heat all the way up to 5 or something like that.
And heat capacity will always be given to you. It's a constant for each element. It's not something that you need to memorize.
Correct. And there's a table on page 293.
Something around there.
I'll check on that. Somewhere in there. So there's a table, and you will be given those as well. Change in temperature. Another thing to know about change in temperature, because the Kelvin scale and the Celsius scale are the same, you can have, so if we go from 25 to 50 degrees C, obviously that's an increase of 25 degrees centigrade. But you could also do the same thing, where you could go from like 273 and then up to 25, I don't know what that is, so 797, 297?
98, but close enough.
Which is also an increase of 25 degrees Kelvin. Yes. So since they're on the same scale, you can use either. So it's going to give you, in your homework, it'll give you problems in Celsius. It's always a good idea to convert to Kelvin anyway. If you don't, it won't ruin you, although it's suggested just in case.
Always check your units.
Always check your units. So, that's what we have. This is what we're going to be using. What's next? Oh, right. So let's look at a couple of practice problems. So practice problem number 1 is in the textbook. It's part of the whole textbook thing, and it is on page 240. So page 240, and we're doing the check your learning. And it says, how much heat in joules must be added to a 5 times 10 to the second gram iron skillet to increase its temperature from 25 to 250 degrees Celsius. The specific heat of iron is 0.451 joules per gram Celsius. So, as always, write down what you're given. Well, the mass is 500 grams. The change in temperature is 25 to 250. So when you're increasing, you're going from 25 to 250, so that's a 225 degree change. So that's the change in temperature. And then the specific heat capacity is going to be your C, which is 0.451 joules per grams Celsius. So now, this is where I check my units. So grams, grams, Celsius, Celsius. So I'm not going to change my units at all because these are matching. I originally did this when Anderson and I were practicing for the video, and she scoffed at me and said, no, check your units. So this is where I'm telling you to check your units. So what that means is that we are solving for Q. And I know that we're solving for Q because I looked at this and I said, oh, what's missing is Q. I'm also know that we're solving for Q because it says how much heat. And you remember that Q is the amount of heat. So, solving for Q means I'm going to use this equation, mc delta T. So Q is the mass, which is 500 grams, times the C, which is 225. Oh, just kidding.
Teamwork. Takes a team.
Takes a team. Times the C, I read that as Celsius. There's where my brain went.
You
times
got
the
this.
C, which is 0.451 joules per grams Celsius. So that means my grams are going to cancel. And I continue on, times delta T, which is 225 degrees Celsius. So my Celsius cancel. Celsius is a word.
That's awesome.
And I do some math, and we end up with 5.05 times 10 to the 4th joules.
Boom.
Boom! I believe this is marker drop. Okay.
Stoichiometry rocks.
Stoichiometry rocks. No,
And
geology rocks.
taking a break.
Picking up, continuing on, it says a piece of unknown metal weighs 217 grams. When the piece of metal absorbs 1.43 kilojoules of heat, its temperature increases from 24.5 to 39.1 degrees Celsius. Determine the specific heat of this metal and predict its identity. So, in this case, we are going to be looking for C. So C is an unknown amount. And so what we have is we have the rest of the information. We have a mass. The mass is the 217 grams. We have a Q, which in this case is 1.43 kilojoules. Now, my answer, I know from last time, is going to be in joules, so I'm going to just convert this into joules really quickly, which is 1430 joules.
Mm-hmm.
So, continuing on, I also have a delta T. Now remember, the temperature is going from 24.5 to 39.1, which means my change in temperature is 14.6 degrees Celsius. So, you'll note that I did this in Celsius because, again, the scale is the same. You can convert to Kelvin, and then if you do that in Kelvin, you will end up with the same difference. And since it's a change in temperature, I'm going to continue in the degrees C. Also, my answer is in degrees C, so it's good to have it that way. Now, when I set up this equation, I'm using this one here. You'll note that it is just the same equation rearranged. All I did was slightly fancy algebra, and magic later, we have a new equation. So C in this case is Q, which is this, 1430 joules. And notice I converted to joules for this one. Divided by 217 grams times the change in temperature, 14.6 degrees Celsius. I do fancy math, I end up with 0.45 joules per gram degrees Celsius. So the second part says, predict the metal that it's most likely to be. To do that, you're going to want it to match the values in table 5.1. And so you will flip back to table 5.1, and you'll find that something very close to 0.45 joules per degrees C is iron. You might be off by a little bit, and that's okay. So as long as the answer is somewhere around and you find a number that is close to the one you have, that is most likely going to be the metal of choice.
Woohoo! Video 1 done.
Awesome.